In this lesson, we'll be moving on to sigma notation, how to evaluate sigma notations, and how to really write an expression into sigma notation. So suppose we're given this question where we asked to evaluate. Label this question A. We're asked to evaluate. So whenever you ask a question like evaluate, in essence, what you need to do, you just need to find the sum of this series, because the sign sigma simply represents the sum. But to calculate the sum, we need to first and foremost determine what type of series this is. We need to determine that. What type of series is that? Is it arithmetic or geometric? And we can do that by really substituting n1 where there's n, substitute 2 where there's n, substitute 3 where there's n, so that we get our first 3 terms. So what you're going to do, you're going to substitute n is equals to 1. N is equals to 1 will enable us to get the first term. N is equals to 2 will enable us to get the second term. And n is equals to 3 will enable us to get the third term. Once we have the first 3 terms, we'll be able to determine whether it's this arithmetic series or geometric series, and then we'll be able to choose the formula accordingly to calculate the sum. So let's go ahead and calculate. So we have 1 over 2 to the power of, where there's n, we're going to substitute 1, minus 1, which will be 1 over 2 to the power of 0, and any number to the power of 0 is 1. Then we go ahead and substitute 2. 2 minus 1 is 1 over 2 to the power of 1. 1 over 2 to the power of 1 is 1 over 2. And we continue. 1 over 2 to the power of 3 minus 1, which will be 1 over 2 to the power of 2. 1 over 2 to the power of 2 is 1. 1 over 4. So we can see our first 3 terms are 1, a half, and a quarter. And really from observation, we can see that this is a geometric series. But we can confirm that by dividing 1 over 2 dividing by 1, because remember, to find the common ratio, take t2 divided by t1, which will be 1 over 2. And we say 1 over 4 divided by 1 over 2 will be 1 over 2. So we can clearly see that our r will be a half. It's a half. And our first term, a, is equals to 1. And remember, when you have to calculate the sum, we have to determine what n is. So to determine what n is, we use an interesting formula that says n is equals to top minus bottom, close brackets, plus 1. Alternatively, instead of saying top, we can say end minus start, then plus 1 in brackets, plus 1. What is the top and the bottom? Are we talking about the end and the start? The top really is the top value, that is 25. It's given there. So it will be 25 minus the bottom value, which is 1, or we can say it's the start, and then plus 1. So therefore our n will be equals to 25 minus 1 plus 1, nothing more than 25, because negative 1 plus 1 will be 0. So now we know that n is equals to 25. So one more thing we need to do. Since our r is less than 1, we know that the sum formula for a geometric series we're going to use is a is equals to 1 minus r to the power of n over 1 minus r. And we do have our r, which is a half, and we have our n, which is 25, and we have our a, which is 1. So we can find really sum of 25 terms. So let's go ahead and calculate the sum of 25 terms. So I'll briefly erase this. We can calculate the sum. So the sum of 25 terms equals to, our a value is 1 minus a half the power of 25, those brackets all divided by 1 minus a half. So the sum of 25 terms will be equals to, grab your calculator and punch all these values in. It'll be 1 minus a half, 1 over 2 to the power of 25 divided by 1 minus half. And you'll see that you get 1,999999994, and really we can just round this off to one decimal place to give you 2. So the sum 25 terms will be equals to 2. So in essence, that's what the question was asking you to evaluate. It was asking you to find the sum of this series. And to find the sum, we have to first determine which series it is, arithmetic or geometric, and then we can use the relevant formula to calculate the sum. So let's move on to the next question. Question B. In this instance, we are asked to determine the values of n, but we are told what? Sigma of n, r equals to 1, 2r plus 3 is equals to 285. So in this instance, they're telling you that the sum is equals to 285. How do we determine n? We start with the first process of determining what type of series this is. Substituting in this instance, we're not given n, we're given r, so we're going to substitute r is equals to 1. That'll give us term 1. Substitute r is equals to 2, that'll give us term 2. Substitute r is equals to 3, that'll give us term 3. So we can go ahead and substitute and use our general term, which is 2r plus 3. It means where there's r, we're going to substitute. We're going to substitute 1 for our first term, which will be 2 by 1 plus 3, which will be 5. That'll be our first term. Then we're going to substitute 2, which will be 2 times 2 is 4. 4 plus 3 will be 7. Then we're going to go ahead and substitute 3. 2 by 3 will be 6. 6 plus 3 will give us 9. So we've determined our first 3 terms, and we can see that this is nothing more than an arithmetic series. We can say 7 minus 5 will give us 2, and we can say 9 minus 7, that will give us 2. So we have our a value for our first term, which is 5, and we have our common difference d, which is equals to 2. And also we're told that the sum is equals to 285. Now we need to calculate what our n value is. So if you recall, some formula for an arithmetic series is n over 2, open bracket 2a plus n minus 1 times d. That is our sum formula. So just to go back and confirm our n value, remember we said our n value is equals to the top minus the bottom, which is 1 plus 1. So n will be equals to n. So it means that we're going to leave n as n in our formula. So we can go ahead and substitute all the values we know. We know that the sum given by 285, n over 2, 2 times our a value is 5, plus n minus 1 and our d value is 2. So now we just go ahead and solve for n. So to get rid of this 2, we can multiply everything by 2, which means we're going to multiply the left hand side by 2, and we're going to multiply the right hand side by 2. What this will do, will cancel the 2 and the 2. And then we're going to have 2 times 285, which will give us 570, is equals to n. 2 by 5 will be 10. Then we multiply n by the 2 to give us plus 2n minus 2, 570. N 10 minus 2 will give us 8 plus 2n. And we continue with this working out. So we have 570 is equals to n, open bracket 8 plus 2n. It will be 570 and multiply n by the n, which will give us 8n plus 2n squared, and we can group everything on one side. 8n minus 570 is equals to 0. So what we can do, we can further simplify this by dividing throughout by 2. To give us n squared is 4n minus 2, 8, 5 is equals to 0. So now what we need to do now is to find the factors of 285, that which we add or subtract, that will give us positive 4, and that which we multiply, it will give us negative 285. And either you can use the quadratic formula, or really you can find the factors. Just find the factors. So if you go ahead and find the factors, you find that the factors are n plus 19, n minus 15. That's equals to 0. If you wish, you can go ahead and plug these values into the quadratic equation, where your a value will be equals to 1, your b value will be equals to 4, and your c value will be equals to negative 285. And the quadratic equation is minus b plus minus the square root b squared minus 4ac over 2a. And in your solutions, you should find that n will be equals to negative 19, or n is equals to 15. But we know that n cannot be a negative number, so our solution is n is equals to 15. And we would have answered the question. So let's move on to question C. We're given that the geometric series is given x is equals to minus 14 minus 9 minus 4, and runs up until 100 terms. And the first question, we're asked to write the sigma notation. So we're not given the sigma notation, but we have to write it in this form. Sigma, we know that we have our end terms there at the top, and then we have n or x is equals to a start value, and we have our general term there. So really we have to determine all of those. But now we are given that it runs until 100 terms, so we have that. We need to find the general term, and then we'll establish our starting value later on. So let's analyze our sequence. So we're given that our series, we're given that it's negative 14, negative 9, negative 4, plus continues. So really we need to establish what this series is. So visually we can kind of like see that it's like an arithmetic series. We can test that by saying negative 4 minus 14, which will give us negative 9 plus negative 9 plus 14, which will give us positive 5. And then we continue. We minus 4 minus 9, which will give us minus 4 plus 9, which is 5. So we can see that we have a constant difference. Therefore, our D value will be 5 and our A value will be negative 14. So now we have all the tools to determine the general term of an arithmetic series, of which it's Tn is equals to A plus n minus 1 times D. Therefore, we can substitute our A value to be negative 14 plus n minus 1, our D value 5. Tn was equals to negative 14, multiplying by 5, we get 5n minus 5. Tn will be 5n minus 14 minus 5 to give us minus 19. So that will be our general formula, of which we can substitute over there. And we know that the end is 100. So really we can determine what our start is. So far we can safely say that our sigma notation stands as 5n minus 19, and we know that we have 100 over there, and with this n we can simply say n is equals to 1, because if we substitute 1 there, it will give us our A value, which is negative 14. And in that way we would have answered the first question in writing our series into sigma notation. It's that simple. So we can move on to the next question. We're asked to calculate the value of x. So how do we go about calculating the value of x? And what is the value of x? What do they mean when they say calculate the value of x? The value of x is nothing more than, really, it says x is equals to the sum of everything. So really we just need to calculate the sum. We already know that's an arithmetic series, so we know that the sum formula we're going to be using is equals to Sn n over 2 2a plus n minus 1 times d. So we'll be calculating the sum of 100 terms. So it'll be the sum of 100 terms, n will be 100, 2 times our A value is negative 14, n, which is 100, minus 1 times our constant difference, which is 5. So we need to calculate what the sum is. Just grab our calculator and determine what the sum is. If you punch everything in the calculator, you should get the total sum value. And the total sum value that we get, 23,350. And that will be the sum of 100 terms of the series. And that will be the answer. And that will be the end of the lesson.